Hello, hello. It's me, and I'm trying to give you notes for tomorrow's class, Section C, Geometric Sequences. I did start this video before, and then I got a phone call, so it interrupted the video and stopped what I was saying. So I had already wrote all of this. Excuse me. So a geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero number called the common ratio. The common ratio we're going to give is R. So a sequence is geometric if and only if u sub n plus 1 divided by u sub n equals R for all values where n is in the set of positive integers. It's fancy Z. Fancy Z. A geometric sequence can also be referred to as a geometric progression. So we're going to put geometric progression here, just like there was an arithmetic progression. Okay. All right, so, excuse me, I apologize. For example, this is just a quick example. If I have 2, 10, 50, 250, dot, 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 that's a geometric sequence because each term can be obtained by multiplying the previous term by 5. So the common ratio, if I did 10 divided by 5, I'm sorry, whoopsies, 10 divided by 2 is 5, 50 divided by 10 is 5, 250 divided by 50, that's 5. So there you go. If I had 2, this is very common when they switch signs, and they give you a sequence like that. The common ratio is -5 here. Okay. The name geometric is actually given because the middle of any 3 consecutive terms is the geometric mean of the terms on either side. That's the same thing as arithmetic. So if you look, so if we have terms that, if I have 3 terms, consecutive terms, then the middle term is the geometric mean of the terms on each side. So if there are, so here's like a kind of more of a definition. If you have terms, or if the terms are A, B, and C, then B over A equals C over B. Therefore, B squared equals AC. Therefore, B equals plus or minus the square root of AC. And AC is the geometric mean. It's a definition. Let's start by that. Okay, so the general term formula, just like we had a general term formula for arithmetic, so the general term formula for the geometric sequence looks like this. So the first term of a geometric sequence is U1. And the common ratio is R. Okay, and so on. So if we can come up with a general formula, it would be U sub n equals U sub 1 times R to the n minus 1. So this n, I'm going to point to the n a little clearer, is the term number. And the n minus 1, right there, is the power of R. That's 1 less than the term number. Okay, so there there we go. This is basically our general formula. So there you have it, right there. All right, so let's move on. This is another example, and this is going to be an example that has some multiple parts. This is in A, B, and C. So example 2, I think. All right, so consider the sequence. Um, 8, 4, 2, 1, 1/2, ... We're gonna A, show that the sequence is geometric. Well, we can do so by finding that the terms have a common ratio, the consecutive terms have a common ratio. So you can do 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. 1/2 divided by 1, or 1, I should say 1 divided by 2 is 1/2. 1/2 divided by 1 is 1/2. So they all have a common ratio of 1/2, okay? So the sequence, therefore, the sequence is geometric. With U sub 1 equals 8 and R equals 1/2. Okay, so let's look at B now. B is, find the general term. Which is just U sub n. So U sub n equals U sub 1 times R to the n minus 1 power. So therefore, if we want to make this, plug in what we know, it's 8 times 1/2 to the n minus 1. Remember, the 1/2 is our R and the 8 is our U sub 1. You could also, I suppose you could also make this a little different in terms of like everything with base 2 power. So we could flip all of this. So if we wanted to combine, if we wanted to make like one concise statement, we could do that. So I'm going to show you how to do that. So we could turn the 8 into base 2, so 2 to the 3rd. We can change the 1/2 into a base 2, where you would do 2 to the negative first, and then you would have n times n minus 1. So I would have 2 to the 3rd times 2 to the, let's see, this is negative n plus 1. And when you add the like powers, you would get 2 to the negative n plus 4, which would be your final answer. So you could either express it like this, or you could say U sub n also equals this. So this and this are equivalent when you change each of these bases, or well, the R and the U sub 1 into bases of 2. All right, part C says find the, excuse me, 12th term of the fraction. Find the 12th term, sorry, as a fraction. I sneezed and can't read apparently. So U sub 12. And I'm just going to make the easier formula. So equals 8 times 1/2 to the, so it'd be n minus 1, which would be 12 minus 1, or 11. And when you go and simplify this, you get 1 over 256. Okay. So there's our example 2. I have a couple more examples, and then we are done with this. So let me go to example 3. All right. So if they say k minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence, and they're going to ask you to find k. Okay, so since the terms are geometric, and they give us 3 terms, we can go back to the very beginning of our notes where we set up this ratio right here when they're talking about the terms are like this, and you know that there's 3 terms and they're saying they're consecutive. So you can actually set up the ratio to look like that. So so if we consider this as A, B, and C, the formula is B over A. So 2K over K minus 1 equals C over B, which is 21 minus K over B, which is 2K. Then you're going to go forth and cross multiply. So I have 4K squared. So I could say therefore 4K squared equals 2 binomials multiplied together. So K minus 1 times 21 minus K. All right, so now what we could do is FOIL this. So I have 4K squared equals, well, I guess we'll do it out of order, it doesn't matter. K times 21 is 21K. So first outer, so that'd be negative K squared, inner minus 21, and then last plus K. And then we're going to get everything over to one side and set it equal to 0. So we're going to just combine our K squareds. So I'm going to add this K squared over here. I'm going to subtract the 2K. I'm sorry. Did I miss something? I think I missed something. Well, this should be 21K. Right? 21K. No. This is just regular 21. And I just missed the 1 here. There we go. I apologize. So 21K and this K get added over. You know what? I really need to redo this. So I have 21K, negative K squared. This should be negative 21, and this should be plus K. Correct? Correct. Okay, so no pun intended. So if I add these two together, I get 22K, but then I'm going to subtract it, so I get negative 22K. There we go. And then I'm going to add over that 21. So plus 21 equals 0. All right, now I am on fire. So I don't know if you've learned this method before for factoring, but if you multiply 5 times 21, you're going to come up with factors that have to multiply, or I'm sorry, add up to 22. So 5 times 21 is going to get you some big